Hi guys, these are our notes on the unit circle, the special angles inside the unit circle. So you can go fill in your table of contents on slide 5. This is our Unit 3 digital notebook. On a piece of paper, you can go ahead and put your title up at the top of your paper. These are notes 3.1.3. We're going to learn about the unit circle. You'll have to write down the essential question, but at the end we want to be able to answer what are the special reference angles on a unit circle. Describe how to create one, how to create a unit circle. So by tomorrow, tomorrow we're going to be creating the unit circle in class. Today we're going to be using the special triangles to find the coordinates of an angle on the unit circle. All right, so first let's look at what these special triangles are, okay? So the special triangles that we're going to look at, the first one is the 45, 90 triangle. Okay, so it's a right triangle and it means that these two angles are both 45 degrees. Well, something that you should know about a triangle where both of those angles are the same, that means that these two sides are also the same because it's an isosceles triangle. If those two sides are the same, then these two sides are going to be called x. And if you do the Pythagorean theorem, that would mean that this side over here is just x times the square root of 2. All right, the other special triangle that we have is the 30, 60, 90 triangle. Here's my right angle, and then my smaller angle is 30 degrees, and my larger angle is 60 degrees. So something that you need to know about a 30, 60, 90 right triangle is that the smallest side is always across from the smallest angle. So my smallest angle is 30, so we're going to call this side x. It's our smallest side. In the 30, 60, 90 triangle, the hypotenuse is going to be 2 times whatever the smaller side is. And the larger leg, not the hypotenuse, but the larger leg is just going to be radical 3 times whatever that side was. So how we are going to use these special triangles, okay, how we're going to use them is we are going to use them as reference triangles in the unit circle. So we're going to use our 30, 60, 90 triangle. I guess I didn't have to put it twice, but these 30, 60, 90 reference angles are going to repeat in each quadrant of the unit circle. Oops. It's 30, 45, 60. I messed up, I apologize. 30, 45, 60 degree reference angles. Repeat in each quadrant of the unit circle. And that's kind of what we looked at on our warm-up today. Is that all 4 quadrants had that same reference angle. So when you're working with a 30, 60, 90 right triangle, since we were on the unit circle, the hypotenuse is actually going to be equal to 1. So when we put this reference triangle onto our unit circle, the hypotenuse is going to be the radius, and the radius of the unit circle is 1. In a 30, 60, 90 right triangle, the smaller side is then half of that, right? Because up here we showed that whatever the hypotenuse was, right? Whatever the hypotenuse was, the smaller side is half of that. So this side is going to be half of that. And the larger side is just radical 3 times whatever the smaller side was. Radical 3 times whatever the smaller side was. So our smaller side is 1/2. So if I multiply that by radical 3, I get radical 3 over 2. We're going to see these numbers repeat a bunch of times in the unit circle. All right, in our 45, 45, 90 triangle, well, we just won't use this one over here. In the 45, 45, 90 triangle, our hypotenuse is 1 because it's going to be the radius, and these other two sides are the same, okay? So the way that they are related is that these two sides you multiply by radical 2 to get the other one. Well, to go backwards then, what we're going to have to do is divide by radical 2. Well, that means that this side is actually going to be the square root of 2 over 2, because if you divide x divided by radical 2, you can't have a radical 2 on the bottom. So 1 divided by radical 2 turns into square root of 2 over 2. All right, so what we need to know is these values right here, okay? So these values are what we're going to use when we do our examples with our reference triangles. So these are the triangles that we need to memorize for the unit circle. Let's go do some examples. We're going to start on page 31 in our new workbook that we've been working in, Unit 3. Example number 1 on page 31 says, find the coordinates of the point where the terminal side of a 330-degree angle intersects the unit circle. Sketch the angle on a unit circle to identify the location of the terminal side, identify the reference angle, find the sine and cosine of each reference angle, determine the coordinates where the terminal side intersects the unit circle. All right, you guys don't have a unit circle on your paper, so you're gonna have to kind of just draw a nice big one at the bottom of your paper. So what we're going to do is we're going to draw a 330-degree angle. So we haven't done a whole lot in degrees, but this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and right back at 0 would be 360 degrees. So your initial side is always that positive x-axis, and then 330-degree angle would be over here in quadrant number 4. So this nice big old angle is 330 degrees. So what it wants us to do is find the coordinates of the point where the unit circle would be, okay? So that's what the goal is, to find coordinates. We want x, y, we want a coordinate pair. What we're going to do is we are going to create a reference triangle, one of those two triangles that we just saw. We want to find this coordinate right here, x comma y. So what we need to do now is identify the reference angle, okay? So to do that, we're going to form a little right triangle with the x-axis. You always draw your right triangle to the x-axis. Well, since this is a 300-degree angle, the reference triangle that we're going to use is the 30, 60, 90 right triangle. The reason why is because if you add 330 plus 30, this would give you a full circle of 360. So if this angle right here is then 30, this angle was 90, that means this angle has to be 60. All right, so when we have a 30, 60, 90 right triangle, remember how I told you guys that the hypotenuse was always going to be equal to 1 because this is a unit circle, so the radius is 1. In a 30, 60, 90 right triangle, the smaller side is always half of the hypotenuse, so it's 1/2. And then the larger leg is going to be radical 3 times that, so it's the square root of 3 over 2. So you need to memorize that those two pieces go together. All right, so the part where it says something about find the sine and cosine of the reference angle, basically, to find your x is how much you move left or right, and your y is how much you move up or down. So the two sides of that triangle, the two legs, not the hypotenuse, the two legs are going to be my x and my y. So how far I move to the right, I move square root of 3 over 2 to the right, and then I move down 1/2. So since I move down, my 1/2 is negative, and that is going to be my coordinate pair. So all of your answers for your coordinate pairs are all going to be these numbers right here. And they go together. So you're either going to have square root of 2 over 2 with square root of 2 over 2, or you're going to have radical 3 over 2 and 1/2 together. All of our points on the unit circle, the special angles, the special reference angles we're going to deal with today are all going to be these numbers right here. Let's do a couple of more examples. All right, example 2 says find the coordinates of the point where the terminal side of an angle with a measure of 5 pi over 4 radians intersects the unit circle. So we want coordinates, so we're going to try to find x, y coordinate pairs. So first thing we're going to do is draw our picture on the unit circle. So since I'm going to have to cut my circle into little pieces, I'm not going to draw the y-axis because it just kind of gets in the way. Okay, so we have 0 radians, pi radians, 2 pi radians. And we're going to go ahead and cut it into 4 slices, and then we're going to use 5 slices. So since the number on top is bigger, what that means is we're going to have to cut both the top and the bottom. So I'm going to cut it into 4 slices on the top, then I'm going to cut it to 4 slices on the bottom, and I'm going to use 5 of them. So I start with my initial side right here on the x-axis. I'm going to use 1, 2, 3, 4, 5 pi slices. So that is my angle. All right, so the goal is to find the coordinates, right? The coordinates are the x, y coordinates. Well, in order to do that, we're going to use a triangle, okay? We're going to use a reference angle with a triangle. So to do that, you're going to connect your point that you're trying to find. You always connect it to the x-axis, and then you form a right triangle with the center. So wherever you are, and if you're in quadrant 1, you would just go down to the x-axis. If you're in quadrant 2, you go down to the x-axis, but if you're in quadrant 3 or 4, you go up to the x-axis from your point. All right, well, the reference angle, remember, is always an acute angle. So my acute angle right here, I know it's kind of hard to see, that acute angle right there is going to be pi over 4 because it's just one slice, right? So that little angle right here is pi over 4. So in my notes page, I should have you guys write down what these angles are in radians. 45 degrees is equal to pi over 4. 30 degrees is equal to pi over 6. And 60 degrees is equal to pi over 3. So those are 3 things that we should kind of commit to memory, is that 45 degrees is pi over 4. How I remember that one is that they both start with a 4. And then for the 30 and 60, I remember that it's the opposite, like the 30 has a 6 on the bottom and the 60 has a 3 on the bottom. It's like the opposite ones. Like they don't have their actual ones on the bottom. But with 45, it's the only one. The 45 and 45 are the same, so it has the same number on the bottom, the 4. So going back to my problem, how it was pi over 4, that means that that one is a 45-degree angle, which means this one over here is also pi over 4, a 45-degree angle. I know my triangle is like so small that it's kind of hard to tell, but both of those are 45-degree angles. Well, if they're both 45-degree angles, what that means is that their sides, the 2 angles are the same, so the 2 sides are the same. This side is square root of 2 over 2, and this side over here is also square root of 2 over 2. To get to this point, remember, this is my point. This is what I'm trying to find. To get to this point, I have to go left and then down. So how much do I go left? Well, I go left radical 2 over 2. How much do I go down? I go down radical 2 over 2. Since I'm in the 3rd quadrant, though, and I go left and I go down, that means that this point is going to be negative x and a negative y. Negative square root of 2 over 2, negative square root of 2 over 2. And that would be my answer. We're going to do a couple more, 2 more examples. The next one says find the coordinates of the point where the terminal side of an angle with measure 3 pi over 2 radians intersects the unit circle. So again, I'm going to draw it. It gave it to me not in degrees, it gave it to me in radians, so I'm not going to draw my y-axis because it gets in the way. All right, so how it works is you go ahead and you cut it into 2 slices. You use 3. Since the number on top is bigger than the number on the bottom, that means I have to cut the top and the bottom. So I cut the top into 2 slices, I cut the bottom into 2 slices, and I'm going to use 3 of them. So here's my initial side. I'm going to use 1, 2, 3 slices, so this is my terminal side. So this is the point where the coordinates, that's what I'm trying to find, is the coordinates. I'm trying to find the coordinates of that point. Okay, so the way that it works, if you are on any of these points right here, any of the ones that are on the x or y axis, you actually don't have to make a triangle. Instead, you should know that the radius of the circle is equal to 1, right? So you can just find the coordinates using that. So you don't go left or right at all. So that means your x-axis is 0, or your x value is 0. And you go down 1, so that means your y is -1. So if you were ever on one of the axes, then your point is going to have zeros and ones in it, a 0 and a positive or -1 somewhere in it. All right, last one, example 4 says sketch the 3 special angles that are located in quadrant 2, label the coordinates of the points where the terminal side intersects the unit circle, use degrees. Okay, I'm going to go ahead and do the 45-degree angle first. The 45-degree angle, so it wants the 3 special angles. That's 30, 45, 60. 30, 45, 60 are the 3 special angles. We're going to be in quadrant 2, which is this quadrant right here. So I'm going to start with the 45 one, which is going to just be directly in the middle of my, my arc right there. And then I'm going to make a 45-degree right triangle. So you go straight down to the x-axis. And then this right here is 45 degrees. Well, if this angle is 45 degrees, then you know that the other angle is 45 degrees, which means that the 2 sides of your triangle, remember, are going to be the same. The square root of 2 over 2, square root of 2 over 2. To get to this point right here, the coordinates to get there, you have to go left and then up. Since you go left, how much do you go left? You go left square root of 2 over 2. So I go left, which is negative square root of 2 over 2. But then I go up square root of 2 over 2, so that one is positive. I need my pen to be smaller to be able to write on this thing. Okay, then I need to do my 30 and my 60. So I'm going to do my 60-degree angle. So it's bigger than 45, right? So this one's going to be 60 degrees. And it's going to go down here to form my right triangle. I'm going to find these coordinates right here. Well, to find those coordinates, remember that the hypotenuse is 1. So across from the 30-degree angle, the smaller one is 1/2, and then across from the bigger side is radical 3 over 2. To get to this point right here, to get to the point, you have to go left and then up. So since you go left, it's going to be a negative. How much negative? 1/2. Then since you go up, it's going to be positive. How much positive? Radical 3 over 2. So negative 1/2, comma, square root of 3 over 2. Okay, last one. I'm going to pick a different color. So I'm going to do a 30-degree angle, which is the reference angle. So 30 degrees is going to be the smallest. This one's 30 degrees. So what happens when you make that 30-degree angle, okay, is we're trying to find the coordinates of this point right here. This color's too light. I use purple. Okay, I'm trying to find the coordinates of this point right here. Well, across from the 30-degree angle is always 1/2. That means this bigger side right here is radical 3 over 2. So to get my coordinates, I go left radical 3 over 2, and then I go up 1/2. So these numbers that you're using, all of your answers tonight are all going to involve these radicals. Radical 3 over 2, radical 2 over 2, and radical 1 over 2, which is just 1/2. So those are the 3 special angles in the quadrant number 2. And those 3 angles repeat in each and every quadrant. You have each of those in all 4 quadrants, which we're going to look at tomorrow in the unit circle. Okay, so these are the notes that we took today. We had just a few triangles that we wrote down. This is what we're going to do tomorrow, which is creating the whole unit circle, all of the special angles, and we're going to look at a lot of patterns. Then you're going to put page 31 and 32 onto slide number 12 in your digital notebook. So yeah, we're going to make that unit circle tomorrow in class, okay? Your homework tonight is page 35, 1 through 9.